Okay, now I want to teach you how to refine mesh. Since why do we need to refine mesh? That's we need to know the reason why. So let's open this LS-DYNA binary file. So the reason is because of when we perform the simulation with this mesh sizes, okay, you can see it clearly where, okay, this one distorted, not like the one we wanted it to be. So that's why we need to refine the mesh in this area. Okay, so for the rigid part, it's not a problem. Also, for the rigid part, we only need to focus on this, on the curvy edge here. Okay, because we don't want to allow any penetration. We want the nodes can read when the node make contact with this another node of the node that belong to of the sheet material, make contact with the node of the dies when it so this contact interface will read the points. Okay, this node will find the nearest point to calculate. Okay, to calculate each the distortion, to calculate the energy. Alright, so meaning that in this case when it try you see, okay, because of this, because of too large length here, okay, to the distance was too far from this point, so it's difficult for the measure for this node to find which point he can use to calculate the energy. Okay, so that's why we need to refine the mesh so that easy. So that's why we need to refine the mesh in this region, and this region of the punch and the die as well. So let's see how to do it. So we stick with the Johnson metal model first. So you go to here, element mesh, you go to element editing, or you go to element tools, you go to element editing. Okay, so you go to split merge and you zoom in. Okay, so which area you want to focus? So in this case I want to use this guy. Okay, so I want to split this, or I tend to select area. So let's look, choose this area here. Okay, let's try to apply. You see, apply, or if you do not certify, you want to add some more, you can just reject and clear. You can select a bit more, but of course when you select too much mesh, this will increase the computation time. Okay, now you have it, right? Okay, then if you accept this, you apply, accept. Okay, then you still do not okay, so then you zoom in, you say that okay, I do not satisfy with this, I want to make the mesh small, even smaller. Okay, what to do? You can choose this here. So I recommend you to use area clear first, and then let's say you want to focus around here. Okay, let's say we choose somewhere around this area. Okay, and then apply, you see there, and accept. Okay, done. We're done with this. So let's say you do not satisfy that, you don't want to have this here. Let's look here what you need. Okay, let's say you want to merge them, you can also do that. Okay, you select this one, you select this, and then you apply. This, and apply, accept, then they match. Okay, so let's say you do it like this, apply, accept, no, editing, merge, select this one, select that one, apply, accept. Okay, see, you have this, they are already merged. And then let's say you want to merge this and that, apply, accept. So then you have make something like this. So let's say you want to turn, you want to cut this half to turn it back to normal. Either you choose this one, do it, apply, you can do this, or you choose this. Okay, you split them, or you choose like this. Okay, apply, accept, or maybe this way, apply, accept, apply, accept. Okay, same. Okay, now I realize that what I need now is to have something like this is not good to have mesh like this. Okay, what I need now, I want to create to make sure that I have the mesh like this, so that they are this knot here have another knot that it can tie to the other the other mesh. Okay, so in this case you have to do it patiently. Okay, so this is the art of meshes. Okay, there are many techniques to create mesh, but I recommend that you make something that having very identical to have this identical mesh sizes as good as you can. So then apply, accept. Now it's better to have 4 knots instead of 3 knot, 4 knot, 3 knot, 4 knots. It's better to have 4 knots, so meaning that in this case this knot here, 1 2 3 4 knots for this mesh, 4 knot for 1 2 3 4 knot for this mesh, 4 knot for this mesh, 4 knot for this mesh. So it's not okay if you have 4 knot for this mesh and then 3 knot for this mesh. So you must not do that. If you want to split like this, no, this is okay, but then this is not good. You have to create another one. So let's say I don't want to do that way. So let's say because of this, so wait, like this, I think, reject. This is not good. If you have 4 knot mesh and then 3 knots mesh, so this is not good. Okay, just an example. So let's just proceed with finish with our mesh here. So since we have a lot of things to do, so need very quick make things. It's not easy, guys. You need to be patient to do this. You can always reject. Okay, we almost finished. Okay, we're done. So we go to the other part. Finite element is very useful if you Refinement elements is very useful if you want to further master degree or PhD. This is going to help you for the analysis, for the modeling. You need to try this to have to learn how to do it. In industry, they have a very specific software. Let's say for tooling, for design the tool, they have very specific software being invented for that purpose. One of them, they call it PAM stamp. But in Europe they use it's quite common to use LS-DYNA and other software. They develop their own software. Okay, so and then I would prefer to split this as well, check. So let's say we choose this. Okay, choose this, apply, and then accept. So accept. What I want to do is we try with this. Let's see. Accept. See, accept. See, accept. This is not good. What can we do is we can reject. Okay, there. Sorry, reject. This like this. Oh no, check. Do this. Yeah, this way is okay. Accept. Yeah, I think it's okay. No need to make it too small. So what you need can do is accept, apply, accept, apply, accept. So let's see what can we do with this. There, no, reject. So what I would recommend to do is apply, accept, apply, accept. You need to have some sort of strategy to do this. Okay, like this. Okay, then this. Okay, this. Okay, I think just enough. Since we assume this is rigid, I think it's okay. Oh, okay, done. Maybe I would love to since we are on it, so maybe we check this guy here, sap, that guy there, sap, 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 let's save as a keyword. So we change the name, let's say this is blanking test 2. Sorry, it's better to have to save them not in the same file, in different file. Two. Okay. Fine. So now we have this part. Then just to let you know that I think just from my experience, I think they have to have done because I forget this, I forget that, sorry, right, check, yeah, accept, right, and then okay, this is okay, yeah, I think this is just nice, I think this is just okay, no problem. Okay, now you need to know that let's just make the others disappear. Why? We go for not editing the duplicate nodes. So you want to check the duplicate nodes, so select by area, by part, okay, or maybe area clear, we choose elements, select area. So this we hide everything, the other parts, because we want to make sure that we select all this part, because when we split the elements, meaning that we alter the nodes number, so it's better to we need to redefine again the part so that everything in order. So now click on show duplicate nodes. You see these duplicate nodes, okay, merge duplicate, okay, and then go to accept. Okay, now we need to do it to the sheet as well, since we split the sheets. Okay, we choose area nodes and then we select all. Okay, are we selecting all? Yeah. Show duplicate node, merge the nodes, okay, accept. Okay, now we hide the sheet and we go blank holder, not needed, no need to check, and because we do not do the mesh editing. So in this case, for the die as well, see this happen, merge, accept. Okay, now we are finished. But due to we adjust the node number, okay, we need to go to this here part here, we must assign this again. So we select all, we go to modify, first we go for the punch, right? So you select by part, we just want to make sure that the part here is modify, and then we do not sure, we click clear and then we click apply, we click punch again, we select the part, okay, by area, and then we select apply. Okay, same goes for the sheet, we clear first, okay, apply, and then sheet, and then by part, and then apply. Blank holder, clear. We clear everything first. We reselect blank holder. Oh sorry, blank holder we don't need to do that since we do not modify a blank holder. So but for the die, we clear, apply, and die. We select the part again and apply. Now we check everything. Punch, this sheet, blank holder, die. Okay, select none. Okay, for the part. For the notes, now see the notes number 3 has been modified. So we go to the punch, we select all. Okay, punch first, clear, and then apply, then click again, select the part. Okay, apply, and the die, clear, apply, click on the die, click on the die again, and then select by part area. Okay, we have it, apply. And for this this is blank holder. We go for clear, apply, and then we go again, we select the part by part, this, apply, and then we finish. So we have now all of them, select all of them. So we check again for this. Okay, no problem. SPC, we need to check this one. Okay, this one. So they are, let's just check. Okay, it's better to check before we perform. Okay, this one, the select ID punch, done. Okay, done. Apply. Select this one, you check the ID. Okay, the die, done. Apply. So this one, we check again, ID, blank holder, done. Apply. Okay, now we are finished. Right, the notes, yeah, I think something wrong. It's okay. We can just name them one by one. Punch is the die, blank holder, apply. Okay, we are done now. Click save. When you alter the mesh sizes, it's better to check everything, because sometimes something weird happen. So the punch movement is SPC 1 2 3. So 2 is what? 2 is the die. 2 is the die. So number 2 die. Number 3 is the blank holder, right? So I think okay, I think nothing is wrong. Okay, so we are all set, we are good to go. Okay, we are good to go. Save. Now we perform the simulations with test 2 run. Let's see how long it takes. So it's gonna take some longer time, since we make the meshes smaller in the shearing zones. Okay, I think halfway, I think something happened. We can look at it, even though it's not finished, but the shearing already occurred, I think. So let's have a look. Blanking, punch, and test 2. Okay, Yeah, we got to see something. Let's see at the stress, at the strain value. See, you can see the difference. Why is it important to it? See here, there's even though there is some penetration, but still acceptable. You minimize the area. So now when you minimize the area, so the sims looks the simulation looks more realistic. So we see this look like this, meaning that it's okay. Okay, so meaning that double nominations. Okay, then you can record this. Okay, you can record this. Oh, let's see, we don't need to record to this. So movie start. Okay, okay, you see what happened. Now we got something to do. Okay, what happened if we change the meta model? Let's see what happened. So you go to the part, you go to the sheet, and then you select, let's say now you don't want Johnson Cook Ludwig. Maybe we try with the worst one, the most basic one, elastic perfectly plastic. What happened? See, accept, done. So then save keyword. Let's look what kind of results we gonna get, so that we can make comparisons between a large mesh with different material model. So it goes very quick. So almost finished, not finished yet, halfway, not almost halfway. In the meantime, you can open this. Are they finished? Yeah, almost. I think we can just save. We can open the file. It's not a big problem. Open the binary and 3D plots. Okay, let's see what happened if we zoom in. So let's look at the plastic strain value. Okay, one more thing, you can also change the background color. You can make it white, you can make it because usually I will choose white if you want to put the slide, crop the file. So let's say I want to crop this, I want to put in the this one I can just hide. If I want to put this simulation in the slide, right? So you just, I can show you how it looks. So this is what you get. And also you can add some video later on in your slide. So you can insert video. What is it? Yeah, video here. Video on my PC. So you go to this. You go to punching. You go to blanking test 2. So then you have it here. Okay, so this is what you get. Okay, let's say in this case you want the background to be white. Okay, or maybe you want it to change to you don't want background, so diameter fit, or maybe you want it to be, you can adjust and try fit. Okay, anything you like. Image, any image you want. So in my case I want it to be plain. and then make video. Start. So you see, looks more realistic than before. When you have large mesh, they just like a very flat shearing. So this is the one where you can see an inclined shearing look more realistic with this elastic perfectly plastic material model. Okay, so inserting this video, so let's say we remove this one, we insert video down here, this one, so we can play. So see the background white. So if you want to play, okay, you want to do the simulation, for example, yeah, you can just, okay, this is what happened. You can zoom in so that you can see it clearly. Okay, so this is just a sample for you. Let's turn it back to your feet. Okay, so you can also choose element shade, height, everything here you can do it, or else you can select something down here. Okay, they are available for you. Okay, same, since this is rendering, okay, you can just choose anything you like, or maybe you want to be like, look like this, or like this, or like this, and remove, and then yeah. So in the end, it's up to your creativity. Okay, let's look here. See, it's not very flat, so it has some, we can say incline due to this. So okay, normal terminations. So let's see, what if we change the part to the last one. We want to see the effect on Ludwig. Okay, accept, done, save keywords, and then we run. Let's try one more last one. So we want to make comparisons to see which one is the most accurate one, and of course the most accurate one, as I explained it, is good if you can perform convergent tests, but in this case, the one I show you is just a method how to do it. So the rest I will leave it to you to do the convergent test. So let's say next semester, if you take a final year project, so you can easily use LS-DYNA to do the simulation of your, let's say, of your model. Okay, let's say if you do the blanking, you can use this finite element, and as well as perform experiment. Okay, you compare both results, experiment between finite element, and then you can also have another analytical solutions. Okay, using form calculation using formula. So then you have three. You can compare between experiments, simulations, results, and these analytical solutions. So then you can see which one is the most accurate. Are they close to each other or not? Okay, in terms of, maybe you want to compare in terms of force. Okay, punch force, for example, or you want to compare in terms of geometry. Okay, now it's finished. Let's have a look at it. I think it's quite similar, except that this one, let's open magnetic plot, linking test tool. So now let's just focus on this. Okay, the shearing here, let's choose plastic shrink. Okay, let's play. See, we see some curvy shapes, and then here, so we can't see too much penetration, so not penetration into the other into the other parts. So this is what you see. as the punch move down, this is very important info when if you want to analyze this from tribological point of view. As the punch move down, there is extra contact between the cut shade, okay, cut edge surface and the punch. Okay, when the punch retract to its original position, you see the punch move up, okay, still having some contact, so meaning that this going to create scoring or galling, and leading to galling to the punch surface. So this is what the most undesired condition, okay, that may occur to the tool surface. I think that's it for okay, I forgot that we can make movie on it, so that we have some okay. Now we have 4. Okay, now we already have like this. No, then we have the next movie where we use Ludwig. So you see, okay, you can see the maximum and minimum value. See, maximum 1.9, around 2. So meaning that we set the strain at failure around 2, right? So this is what happened. If we set 1.6, it's going to reduce to up to 1.59, something like that. So I think that's it for the finite element simulation. Okay, thank you.